This videotape, the second in our series on trigonometry, involves definitions of the trig functions and some identities. In the last tape, we studied angles and how to measure them. Now we are ready to actually define the trig functions. Our definitions of the trig functions will be for angles of any size. Now, some of you may have studied trigonometry earlier. If you have no prior knowledge of trigonometry, don't be upset. You can get all your knowledge from these tapes. Okay, but if you have studied trigonometry earlier, and you studied trigonometry, the trig functions defined for acute angles, okay, that is angles between 0 and 90 degrees, or trig functions for angles in a right triangle. Okay, you learn certain definitions for trig functions. The definitions that I'm going to give you now may seem a little confusing. In a few minutes, however, I will show that they are consistent with your earlier definitions. As I mentioned, if you have no prior knowledge of trigonometry, don't be upset. You can get it all from these tapes. Okay, let's start in the following way. We're going to define 6 trigonometric functions. These will be for functions for angles of any size. Okay, we will start with an angle in standard position. And we have our coordinate axes. We're going to take an angle A in standard position, that is, one whose vertex is at the origin and whose initial side goes along the positive x-axis. And let's make it a second quadrant angle. That is, its terminal side is in the second quadrant. Here we have a typical angle A. It is a positive angle generated by a counterclockwise rotation. All of these terms were defined in trig tape number 1, which of course you should see before viewing this tape. Okay, we have an angle A in standard position. Pick a point, any point on the terminal side of angle A. And let's call this point P. Any point at all on the terminal side of angle A. Let the coordinates of point P be x comma y. Okay, point P on the terminal side of angle A has coordinates x comma y. Here, of course, is the origin. Let R represent the distance between point P and the origin. R represents this distance. Okay, let's go over what we've done. We've taken an angle A in standard position, vertex at the origin, initial side along the positive x-axis. We've taken any point whatsoever on the terminal side of the angle. We've taken this point P, and its coordinates are x comma y. R represents the distance of between this point P and the origin. Okay, bearing all that in mind, we define the following 6 trig functions. Sine of A. By the way, this is an abbreviation. Sine is actually S-I-N-E. Okay, this is the abbreviation. Sine of A. We're going to define cosine of A. It's really C-O-S-I-N-E. We just abbreviate C-O-S. Cosine of A. Tangent of A. We'll also define cosecant of A. That's the abbreviation for cosecant. Secant of A. And cotangent of A. These definitions will all be in terms of x, y, and r. Okay, sine of A is defined to be the y coordinate of point P over r. Cosine of A is defined to be x over r, and tangent of A is defined to be y over x, where it's assumed that x is not 0. For example, if point P were here on, point P were on the y-axis here, so that any point on its terminal side, okay, if we had an angle of 90 degrees, any point on its terminal side would have to have x coordinate 0. We see that tangent would not be defined for such an angle. Okay? So this is the definition. The tangent of an angle A is y over x, assuming that the angle is such that x is not 0. Okay, in the second column, these, by the way, the 3 most popular trig functions. These trig functions are used a little less often. Cosecant happens to be the reciprocal of sine. It's defined to be r over y. once again, since we're dividing by x or y, something which could be 0, we have to specify that y is not 0. Secant is the reciprocal of cosine. It's r over x, where x is not 0. And cotangent of a is the reciprocal of tangent. It is x over y, assuming y is not 0. Okay, I will not always write these stipulations that certain things not be 0. We know in our mathematics the definition is only valid, of course, if there is no division by 0. So even if I just write tangent of a is y over x, you know that it means x is not 0. Okay. Sine of a is y over r. Cosine of a is x over r. Tangent of a is y over x. Cosecant of a is the reciprocal of sine of a. It's r over y. Secant of a is the reciprocal of cosine of a. It's r over x. Cotangent of a is the reciprocal of tangent of a. It is x over y. Okay, now, I am going to direct this portion of the tape basically to those of you who have some prior knowledge of trigonometry. If you did study trigonometry earlier, then you studied it probably for acute angles. And trig functions were defined for acute angles, angles between 0 and 90 degrees. From our point of view, this would mean that the angle was a first quadrant angle. Okay? Let's put down a first quadrant angle, like so. This could be our angle A in the first quadrant. We will pick a point P on the terminal side. Let's say this is x comma y. Okay, and r represents the distance between that point P and the origin. All right, now, if you wanted to, you could drop a perpendicular from point P to the x-axis. This would finish off a right triangle. Now, x, y are the coordinates of point P, which means that the length of this leg of the right triangle is x, and the length of this leg is y. In other words, this point P is x over and y up. So if the angle A is in the first quadrant, okay, then you can think of it as an acute angle in a right triangle, the legs of which are x and y, and the hypotenuse, the side opposite the right angle, has length r. Now, let me write down the definitions that I gave you for sine, cosine, and tangent. Sine of A is y over r, cosine of A is x over r, tangent of A is y over x. These are the new definitions that I have given you. These are for angles of any size. I would like to show you that if the angle A is in the first quadrant and can be thought of as an acute angle in a right triangle, these definitions will reduce to the ones that you learned earlier. Let's look at this angle A in this right triangle. Y is the side that is opposite angle A, and r is, of course, the hypotenuse. Those of you who studied trig earlier probably remember that sine is opposite over hypotenuse. The sine of an angle is the length of the side opposite the angle over the length of the hypotenuse. This is, of course, consistent with that. If the angle is in the first quadrant, y over r represents the length of the side opposite the angle over the length of the hypotenuse. Similarly, x is the side adjacent to angle A. Y is opposite angle A. X is adjacent to angle A. R is the hypotenuse. And you probably learned cosine as adjacent over hypotenuse. And finally, y over x for tangent. Y is the side opposite, and x is the side adjacent. So we have tangent is opposite over adjacent, which is also the way you remember it. In fact, we have a neat mnemonic for remembering that sine is opposite over hypotenuse. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So those of you who learn SOHCAHTOA, okay, as a mnemonic, a way of remembering the definitions of the trig functions, I want you to realize that these definitions still hold if the angle is in the first quadrant. The advantage to these new definitions that I've given you over here is that these are valid for angles of any size. Okay, if the angle A is in the first quadrant, by all means use your SOHCAHTOA definitions. These are equivalent to SOHCAHTOA. But if the angle is outside of the first quadrant, okay, SOHCAHTOA is not directly applicable, and these definitions are. So in a sense, these are better for us. Okay, they are good for angles of any size, whereas the SOHCAHTOA definitions were only for acute angles, angles between 0 and 90 degrees. Okay, going back over here, some of you may be troubled by this business of taking a point P on the terminal side. Okay, these trig functions are functions of the angle A. They only depend upon the angle A. Somebody might say, well, look, I mean, X and Y are involved, and that was determined by where I picked my point P. So doesn't it make a difference where you pick the point P on the terminal side? The answer is it doesn't. Let's say we picked another point P, okay, maybe one closer to the origin, round over here. Okay, and we had dropped our perpendicular and formed a right triangle in much the same way. The x-coordinate of this point would be smaller than the x-coordinate of that one. The y-coordinate would be smaller, and r, the distance between the origin and the new point P, would also be smaller. But because this smaller right triangle is similar to the larger right triangle, the trig functions, the ratios, opposite over hypotenuse, adjacent over hypotenuse, would all be the same. For example, sine is opposite over hypotenuse, or y over r. Now, y is a little smaller, and r is a little smaller in the smaller triangle, but y over r in the smaller triangle will be the same as y over r in the larger triangle, because corresponding sides of similar triangles are in proportion. So it does not matter where on the terminal side of the angle you pick the point P. Okay, if you picked it a little further out or a little closer in, okay, when you draw your right triangle, you will get a similar triangle, okay, to the one that I have over here. And therefore, the ratios, when you take, okay, say y over r, it'll be the same. The ratio will be, although y is smaller, r is smaller or bigger, the ratios remain constant. Trig functions are functions of the angle. It does not matter where on the terminal side you pick the point. Now, what I would like to do is write down some relationships which come out of these definitions of the trig functions. Okay, we're going to be sticking with these definitions, the new definitions. As I said, if the angle is in the first quadrant, your SOHCAHTOA definitions are perfectly okay. We won't be needing these right now. We're going to concentrate on these. Okay, the first, we're going to try to accumulate relationships between these trig functions, which will be convenient for us to have in our future work in trigonometry. Okay, the first relationships that sort of jump right out at us are the reciprocal relations that I mentioned a little earlier. These are the most elementary type of trig identities. The fact that cosecant A is 1 over sine A. Cosecant is the reciprocal of sine. Okay, obviously y, if you have 1 over y over r, you invert and multiply, and you get r over y, which is cosecant A. Secant A is obviously the reciprocal of cosine A. Secant A is 1 over cosine A. And cotangent A is 1 over tangent A. In all instances, I'm assuming that the angle A is such that we do not have division by 0. Okay, by the way, one could also write these reciprocal relations in the other way. For example, sine A is clearly 1 over cosecant A. These, however, are usually the more convenient form because people are more familiar with sine, cosine, and tangent. And should they get a problem involving, say, cosecant, secant, or cotangent, very often they would like to put it in terms of sine, cosine, and tangent. And these reciprocal relations provide a means of doing that. Okay, if you have to deal with the cosecant of A and you would rather not, you could think of it as 1 over the sine of A, which you may be more familiar with. So here we have the 3 reciprocal relations. Okay, the last thing I want to do in this particular videotape is the quotient relations. These are 2 other important relations or identities from trigonometry, which come right from the definitions of the trig functions. By the way, in the next few tapes, we'll be expanding our list of trig identities or trig relationships. We have in this tape the reciprocal and the quotient relations. And in the next few tapes, we'll be getting many more relationships that are important for us, and we'll be learning how to work with them. Okay. If we look over here at sine, cosine, and tangent, something may occur to us. Sine is y over r. Cosine of A is x over r. Tangent is y over x. So we see that there is a certain relationship here. Namely, if you were to take sine A and divide it by cosine of A, if you were to take sine A divided by cosine of A, y over r divided by x over r. Okay, to divide by x over r, you would invert and multiply. The r's would cancel. You would get y over x, which is tan A. Let me write that down for you here. Sine of A, as I said, is y over r. Cosine of A is x over r. If you were to take sine A and divide it by cosine of A, you would get y over r divided by x over r. Now, we all know to divide by that fraction, we can invert and multiply. So instead of dividing by x over r, we invert and multiply by r over x. The r's cancel, and we get just y over x. But if you remember y over x, look back at your definition, y over x is simply tangent A. Okay? So sine A over cosine A is tangent A. This is the first of our quotient relations. If you have a problem involving the tangent of A, and if you feel more comfortable with sine and cosine, you can write that tangent of A is sine of A divided by cosine of A. Once again, assuming that cosine of A is not 0. In a similar fashion, okay, you can take the cosine of A divided by the sine of A. If you do that, you would get just the reciprocal of what we have here. In other words, we'd have cosine over sine, we'd have this over that. The answer would be the reciprocal, it would be x over y, but x over y is our definition of cotangent of A. So we have that tangent of A is sine A over cosine of A. Cotangent of A is cosine of A over sine A. And these will be helpful for us to have later on. And this brings us to the end of our second tape on trigonometry.